Hello everyone, myself Sneha Murthy. I'm studying in Sri Venkateshwara College of Engineering. Today we are going to discuss a topic called undecidability, a language that is not recursively. And the next is first the topic is a language that is not recursively enumerable. The concept of undecidability in computability theory explores the fundamental limits of what can be computed. This presentation will delve into the intriguing idea of a language that is not recursively enumerable, shedding light on the profound implications of such a finding. This is the introduction to the undecidability. Here, in the picture, we can see all the things which are present in the undecidability. Next is introduction to computability theory. The first is computability means the study of what can and can't be computed by algorithms and Turing machines. This is called computability. The next is decidability, determining whether a given problem can be solved by Turing machine in an infinite number of steps. This is called as decidability. Next is recursively enumerable sets. The set of strings that can be generated by using a Turing machine that halts on all the inputs. This is all about the introduction of computability. Here we can know the definitions of computability, decidability, and recursively enumerable sets. This is they are given in a row that is of 1 0 0 1 0 and lastly null. So this 0 is called as a transition function, and all this the green color row is called as unbounded tape, and the blue one is finite state, and the red color which is present in the arrow mark is head position, and this is a transition function, and this is the halt move or decision. Next is formal languages and Turing machine. The formal languages means a formal language is a set of a string over a finite alphabet which is defined by a set of rules. And the next is Turing machine. Here the formal language is a set of strings over an alphabet which is defined by the rules. The alphabets which are present in a formal language that is defined by a rules is known as a formal language. And the next is Turing machines. Turing machines are the mathematical models of a computation that can decide and recognize the formal languages. Here the formal languages are recognized by the mathematical models computation that can recognize over a formal language is called Turing machine. And the next is equivalence. Turing machine and the formal languages are intimately related with each defining the other's capability. The both formal languages and Turing machines together we can call as an equivalence. This is all about the formal languages, Turing machine and equivalence. The next is recursive and recursively enumerable languages. Here we can see three types, that is recursive languages, recursively enumerable languages, and the relationship. First is the languages that can be decided by a Turing machine that halts on all the inputs. The inputs which be given by to the machine, the language will decide. The language will decide how the Turing machine gives all the inputs. The next is recursively enumerable language, which defines the language that can be enumerated by a Turing machine but may not halt on all inputs. This is all about the recursively enumerable language. And the next is last one is relationship. Recursive languages are the subset of the recursively enumerable languages with important implications. In the relationship, we can see the implications which are present in the recursively and enumerable languages. In this picture, we can see how it works actually. The function call 1 is present, function call 2 with function call 3 and function call 4. All the function calls are present in this example so that we can exchange the stacks from these functions. And the next is the halting problem and the undecidability. First is the halting problem. Determining whether a given turning machine will halt on a given input or not. We have to determine whether a given turning machine will halt on a given input or not. And the next is undecidability. The halting problem is undecidable, meaning no turning machine can solve. The undecidability refers to turning machine can solve it, that is, no turning machine will solve these undecidability problems. Next is implications. Undecidability has profound implications for the limits of computation and what can be computed, and undecidably profound implications for the limit of computations and what can be computed. So these are the halting problems and the undecidability which are present in this divorce. This is all about the halting problem and the undecided. And the next is diagonalization and the halting problem. First, in the diagonalization and the halting problem, there are three types. That is of first, we have to study the definition about the diagonal argument and the diagonalization and implications. The implication is common in all the techniques. First is diagonal argument, a technique used to prove the undecidability of the halting problem by constructing a language that can't be recursively enumerated. And the next is diagonalization, a method of comparing the sizes of the different infinite sets, leading to the conclusion that the halting problem is undecidable. And the next is implications. The undecidability of the halting problem has it has to face some consequences for the limits of the computation and the decidabilities. This is all about the diagonalization and the halting problem. Next is defining a language that is not recursively enumerable. First, we have to know the definition about the language. Language defines the constructing a language that can't be generated by any tuning machine. And the next is diagonalization, using a diagonal argument to show that the language is not recursively enumerable. And the next is undecidability, demonstrating that the language can't be undecidable through the tuning machine. It is undecidable. This is the definitions which we can learn from this. First is language, next is diagonalization, and the next is undecidability. Next is proving that the language is not recursively enumerable. First is assumption, the language is recursively enumerable. And the next is contradiction, constructing the Turing machine that can enumerate the language, which leads to a contradiction. Next is conclusion. The language is not recursively enumerable and therefore it is not decided by any Turing machine. These are the three conditions that we can prove that the language is not recursively enumerable. The next is applications and the implications of undecidability. First is theoretical implications. In theoretical implication, undecidability reveals the fundamental limitations of computation with profound implications for computer, science and mathematics. Next is the practical applications. Undecidability has the applications in areas like the cryptography, program verification, and the design of the decision-making systems. And the practical applications we can use like in the areas like the cryptography and the program verifications and even in the decision making systems. And the next is future directions, means how this undecidability can be used for the future people and future exploration. That is, by exploring the boundaries of the decidability and the undecidability, it continues to be an active area of the research in computability theory. These are the three applications and the implications of undecidability, which we can use. The first is theoretical implications, next is the practical application, next is the future directions. And lastly, the final conclusion is, first is significance of undecidability. The discovery of the language that is not recursively enumerable has profound the implications for the limits of computation. This is the significance of the undecidability, and the next are the open questions that may occur, further exploring the boundaries of the decidability and the nature of the undecidability. Problems remains in an active area of the research. This is the question that may occur in the decidability and undecidability. And the next are the future directions. Investigating the practical applications and impractical applications, ramifications of the undecidability that continues the advancement in the computability theory. So in this lecture, closed-ended questions and open-ended questions are given. The closed-ended questions that may occur: do you like our product or a service? Do you find this meeting helpful? Would you consider using our product or a service again? So these are the closed-ended questions, and the open-ended questions are: what do you find the most useful about our product or a service? How do you feel about this meeting? What would make you consider using our product or a service again? So these are the questions which may occur in this undecidability. Thank you.